Neural networks are the backbone of AI tools like ChatGPT and image recognition. Today, we will create your first neural network step by step, no prior experience needed. Welcome back, learners. I am Shahid, an AI ML specialist with 10 years of experience in the field. My goal to help you become an AI ML pro with practical and easy to follow tutorials. Don't forget to like, subscribe, and share this video with your friends so they can join the journey too. Today, we will build a basic feed-forward neural network using TensorFlow. By the end, you will understand how neurons work together to make decisions. Let's dive straight into the program and break it down step by step, explaining each part thoroughly. The first thing we do in this program is import some essential libraries. We import NumPy for numerical operations, TensorFlow for building and training our neural network, Matplotlib for plotting and warnings to suppress any unnecessary warning messages that might clutter our output. So the first thing is we import the libraries. So run this cell and we have imported our libraries. Next, we will begin, we'll begin explaining the purpose of the neural network. Now, a neural network is essentially a set of algorithms that tries to mimic the way our brain works to recognize patterns or relationships in data. The particular type of neural network we will be building here is called a feed-forward neural network. In this type of network, information only flows forward from the input layer through to the output layer without any feedback loops. Okay, so this is about the neural networks. Next, we move on to generating our data set. In this program, we are generating a data set that represents two types of shapes, that is circles and squares. So these shapes are defined by simple features. A circle's feature is its radius and a square's feature is its side's length. Okay. So along with this, we also define labels 0 for circles and 1 for squares. Okay. So here's the function. Okay, is generate underscore shapes underscore data, where we create random circles and squares. Okay, so for each sample we randomly choose a label 0 or 1 to indicate whether it's a circle or square. So if it is a square, we pick side length between 1 and 2 and the label is set to 1 for square. If it's a circle, we randomly pick a radius between 0.5 and 1.5. Okay, so and we will store it as the feature along with the label 0 for the circle. Okay, so we collect these features in the list X and the labels in the list Y. Okay, once the loop completes, we return X and Y as NumPy arrays. Okay, so now we generate this data set. Okay, generate this data set and normalize the data. Okay, normalize it. So normalization is crucial because it ensures that our input data has the same scale, making it easier for the model to learn. Here we apply minimax normalization, so which scales all the features in the range of 0 and 1. Okay, 0 to 1. So this helps with the convergence of the model during training. So we then split the data into training and testing sets using the train underscore test underscore split module from the sklearn model selection. Okay, so we'll run this cell and so this function is now programmed. Okay, so the next thing is when we split the data set into training and testing sets, here 80% of the data is used for training and the remaining 20% is used for testing the model's performance. So the random state equal to 42. Now this random state parameter ensures that the split is reproducible each time you run the code. Okay. So the next is, here comes the fun part: building the feed forward neural network. Okay. So here, okay, so you can see we have a cell with different lines of codes. This is where we define the structure of our neural network. The first one is the input layer. Okay, the first layer is a dense layer with 16 neurons. Okay, 16 neurons and the ReLU activation function. The input shape 2 here, the input shape 2 here indicates that the model will take two features as input. Remember, each shape has two features like radius for circles or side length for squares. The next one is hidden layer. So the second layer is also dense with 8 neurons and ReLU activation. Okay. The output layer, the output layer is a dense layer with a single neuron and is a sigmoid activation function. Okay. Sigmoid activation function, which is ideal for binary classification. So this will output a probability score between 0 and 1. Okay. If the score is closer to 0, we classify it as a circle. If it's closer to 1, we classify it as a square. Okay. So next we will compile this model. Okay. So here you can see there are 20 epochs which has been carried out, and you can see the validation accuracy of the model, okay, has reached almost it's 100%, and the losses are minimum. Okay, you can see the losses it started from 0.75, okay, and it got significantly reduced, and at last epoch it is 0.0949. It means that with every epoch the model's accuracy is increasing, or you can say the loss is minimized. Okay, so we use the Adam optimizer for training the model. Okay, because it adopts the learning rate during training and making it more efficient. Okay, the binary cross entropy. Okay, so the binary cross entropy here, it is a loss function which is used because we are dealing with a binary classification problem. Okay, so the binary cross entropy will be used wherever we deal with a binary classification problem, either a circle which is denoted by 0 or a square which is 1. We also want to track the accuracy of the model during the training. So now we train the model. Okay, so to train the model, so we will just compile this code. Okay, now you can see we have achieved a test accuracy of 1. Okay, so we train the model for 20 epochs with a batch size of 32. Next, the validation split is equal to 0.2, means 20% of the data, okay, will be used for validation during training, allowing us to monitor how well the model is generalizing. Okay, after training, we evaluate the model, okay, for this performance on the test set. So the next thing, okay, so the evaluate function, okay, the evaluate function used here, okay, computes the loss and accuracy on the test set, and we print the accuracy value to see how well our model performs on unseen data. Okay, so now the next step is let's visualize the training results. Okay, it's always a good idea to track how the models performs over time. Okay, so the code here, okay, in this cell, this code plots the training accuracy and validation accuracy across epochs. Okay, so we use history.history. Okay, history.history with accuracy. Okay, and history.history with validation accuracy to extract the accuracy metrics during training and validation. The plot helps us to understand if the model is overfitting, underfitting, or learning effectively. Okay, so we'll just compile this. Okay, and let's see. So this is the visualization where we can see how the accuracies are training accuracy and the validation accuracy is varying. Okay, across the epochs. Okay, so finally the next step is making predictions. Okay, finally we define a helper function to classify shapes based on their features. Okay, so this function accepts a list of features. Okay, that's the line of codes written in this cell. So this function accepts a list of features, for example radius or side length, and predicts whether the shape is a circle or square. Okay, the model returns a probability score, and if the score is below 0.5, we classify the shape as circle, and if it's above 0.5, we classify it as a square. Okay, so we then test the function with a sample input. Okay, so we'll run this, compile this, and we can see. So the predicted class is circle. So here we input the features for a circle and with a radius of 1.2 and print the predicted class. If everything is working correctly, the model should classify this input as circle, as we can see in this output. Okay, so by the end of this process, now we have built a simple neural network capable of distinguishing between two types of shapes based on their features. So this exercise demonstrated how to generate synthetic data, normalize it, split it, build a model, train it, evaluate its performance, and finally use it for predictions. Okay. If this session excites you, our 30-day bootcamp is the perfect way to take your learning further. Here's what waiting for you: hands-on learning with TensorFlow, Keras, and more, projects like chatbots and image classifiers, certification and bonuses worth rupees 12,300. Join now for just rupees 499. Seats are limited, so act fast. Link in the description. Like, share, and subscribe for more engaging AI/ML tutorials. Let me know your thoughts in the comments, and I'll see you in the next video.